Hello. Today in this video, I'll be talking about supervised and unsupervised learning. I'll cover features and labels, the difference between the two paradigms, regression, classification, and clustering, and some examples or applications of this. Imagine you're a high school student and you're given the opportunity to take one of two assessment tasks at school, but you can only choose one. The first is a worksheet that you can fill your answers out on, and it's accompanied by an answer booklet, which the teacher can use to mark your work, comparing the correct answers and your answers. The second is a project. It's similar in spirit, but there's no strict correct answer. You are given the opportunity to explore and find patterns for yourself. Which do you choose? That's the classic question of supervised and unsupervised learning in machine learning. The supervised learning is the first task, and unsupervised learning is the second task. Before we explore what each paradigm is, we need to understand features and labels. A feature is like a clue that you use to predict something, a piece of information that can help you make a prediction. For instance, if you wanted to predict house prices, the most logical features would be the house size, the number of bedrooms, and whether there's a pool or not. These are all relevant features that contribute to or have a significant influence on the house price or what we want to predict. Feature quality matters too. A model trained using the feature number of bedrooms would be significantly more accurate than a model trained on the feature roof color. It makes sense because the first one, number of bedrooms, has a much more significant influence or impact and it's more correlated with the house price than roof color. These help make more accurate models. A label is the true answer, the thing you want to predict. In our example for the house price, the label would be the actual house price itself. And the goal of machine learning is to use these features to predict this label. Our prediction is an estimate of that label given the features. We want to make this prediction as good as possible. So we want to minimize the loss or measure the wrongness between the label and the prediction. We want to find the optimal model that makes this measure of wrongness as small as possible to make the best possible predictions. Supervised learning utilizes both features and labels, in which the goal is to find a model that can map our input, X, or the features, to the label or the output. The key distinction is that supervised learning uses label data, meaning there's an answer, there's something we are actually concretely trying to predict. It makes sense because it's supervised, as in supervision, where there's an answer booklet. Regression is one of the most classic examples of the supervised learning. And in regression, the label is a continuous value, meaning it can be 5, 6.6, negative 4.5, any number basically. For example, predicting house prices is regression because the cost of the house, the price of the house, is going to be a number we can actually define. For instance, 1 million or 2 million. Some examples include stock market prediction, temperature prediction, as it can be 34 degrees, 20 degrees, 19 degrees, or sales forecasting. What sets the regression apart is that we want to predict a number or value. In the house prices example, we are trying to predict the cost. Regression tasks are useful, like the house prices one, because it helps us manage to find out an actual value which we can use. In the house prices example, it can help us decide which house to buy depending on how pricey the house is. That's one type, but there's also classification, in which the label is discrete or categorical. Instead of being any number, like 5 or 50, the label has to be a category. For instance, spam or not spam, animal or plant, or medical diagnosis, whether you have the condition or you don't have the condition. So we have boxes or categories in which we want to classify samples into. We're not necessarily trying to predict an actual number this time. We're trying to classify things into predefined groups, predefined categories. And we want to predict a class for this. The most classic example is a spam filter for emails, in which the classification task is to classify emails as either two choices, spam or not spam. As you can see, this is not regression because we're not trying to predict a number value, for instance, a spam score like 6.9 or 10.2. We're trying to predict two concrete categories and classifying the email into one of these. Unsupervised learning is a bit different, and as the name suggests, it doesn't need supervision. In machine learning, we define unsupervised learning as a task that requires no labels. So how does the model learn without the actual labels, the answer? How it works is the model looks at just the features and it groups them, or like tries to find patterns in the data just by looking at the features. So it's trying to figure out some patterns in the data without actual answers. So it's basically, there's more autonomy to it. You do it more yourself. An example is customer segmentation, in which we would group shoppers into distinct groups, even when they don't have labels like frequent shopper or not frequent shopper. You look at the patterns yourself, and based on the purchasing frequency, cart size, or browsing habits, the model just naturally learns to figure out the patterns in the data itself. There are no labels, so this is unsupervised. This is called clustering. There's no labels. You have to figure it out yourself. And we learn patterns without supervision by clustering these samples into distinct groups. Thank you for listening.